This video will be a brief revision on state of matters, which is chapter 1 and chapter 5. Okay, so you've learned earlier about solids, liquids, and gas. Okay, solids, they are close together. So this is the distance. They're close. Liquids are still close. And gas, they are very far apart. We have their movements. Solid only vibrates. Liquids, remember, they move in and out of each other. In and out. Or we can call it slide over. Remember, there's two terms to use. Slide over each other. And gas, they bounce in all directions. Randomly. Okay, what about their pattern? Solid has a regular pattern. Liquid, irregular. So although they're close together, but they don't have any regular pattern. So it's random, but close together. Whereas gas, they are totally far apart and irregular. So you can see liquids is like the in-between of gas and solid. Okay, so solids can become liquid, liquid can become gas, and the process is called, this one, melting. And this way, freezing. And liquid to gas, there's two. One is boiling. And the other one is evaporation. And what's the difference between boiling and evaporation? Boiling, you need to provide heat. So I'm going to draw heat. Okay. Evaporation, no need. You don't have to provide any heat. Evaporation can happen anywhere. Okay, evaporation, it only happens on the surface because you didn't provide any heat. But boiling, because you provide heat throughout the whole liquid, it will start to boil and it will become gas. Okay, but evaporation, only the surface particles will escape and become gas. Okay, the other way around, that's condensation. And some substance like carbon dioxide, dry ice, they skip liquid, so they can go directly from solid to gas or gas to solid, and that we call sublimation. Okay, how to know the state of a matter if we know the melting and boiling point. So let's say I have a temperature line here. And let's say room temperature is somewhere 25 degrees Celsius. That's around our room temperature, maybe in a mildly air-conditioned room. So generally we'll say room temperature is 25 degrees Celsius. Okay, so if something, it melts at, say, negative 196, this is its melting point. And its boiling point is negative 20. So by 25, it is going to be a gas. So we look at the line of temperature here. Okay, what if something melts at 200? So 200 is above 25. And maybe it boils at 1000. So we look at this. So at 25, it hasn't even melted. So if it's not melted yet, so therefore it's still a solid. Okay, what if something else, it melts at 0, and it boils at, say, 98. So room temperature is somewhere here. Therefore, this one is a liquid because it has already melted at 0. And by 25, it hasn't boiled yet, so it's a liquid. So this is how we find out whether it's a gas, solid, or liquid by looking at its melting and boiling points. So these are examples of 3 different substances. Let me put the color there. So that's a gas. This one is a solid. And the last one is a liquid because 25 is in between its melting and boiling point. Okay, the next thing that you need to revise is the diffusion and dissolving. So remember the coffee cup. You have a coffee cup and there's hot coffee inside it. And you put sugar into it. Okay, so the first thing that would happen is it will dissolve. Now, what's dissolve? Dissolve is when it starts to bond together with the water that's inside. So it's chemically bonded, although weakly, but it's chemically bonded, and they go in between each other. Okay, so the first thing, it will dissolve, so it's bonded already. But after it's chemically bonded, then there's more of the sugar concentration on this side, because we put in the sugar on this side. So the sugar, most of it just dissolve on this side. So what's going to happen next is diffusion. Okay, when it diffuses, what happens? It will go from the side where there's more of it to the side that there's less of it. And we don't have to do anything. I don't even have to put a spoon in to stir it. So the side that has a higher concentration, the particles will go towards the side with lower concentration. And eventually the whole cup will taste sweet. So that is diffusion. Now, what are the other examples of diffusion? Do you remember? For example, if someone cooks in the kitchen and you walk through the front door that's so far from the kitchen and you can smell the food. So that is diffusion because the particles from the food in the kitchen, that side there is higher amount of the food particles in air. So it will fly or escape towards the side in your house, the living room, where there's less of the food particles. So eventually it goes near your nose and that's when you smell the food. That is also an example of diffusion. Okay, how to make diffusion faster? So what's going to affect diffusion? Factors that affect rate of diffusion. Okay, one thing is the state. What state? Solid, liquid, gas. So of course, solid will be the slowest because we know that it doesn't move around. Solids only vibrate. So it won't happen so fast, it only vibrates. Liquids slightly faster because they move in and out of each other and slide over each other. A gas, it moves the fastest because it bounces everywhere in all directions randomly. So the food particles that's in the kitchen air will just randomly move into the living room air So you can smell the food particles if the state is in gas. Okay, second thing is the temperature. If the temperature is cold, the rate of diffusion will be slower. And if the temperature is hot, the rate of diffusion will be faster because it has more energy. Therefore, it bounces even more compared to being cold. So this is why you see hot coffee, you can smell it from further away compared to cold coffee probably. So things that are hot, they have more energy, so they move faster. So the rate of diffusion will also be faster. Okay, the third thing that affect this rate of diffusion would be the mass. Remember how to get the mass? That we'll have to look at the periodic table. Now, where to get the mass? The mass is the figure from down here. So things that have low mass, they diffuse faster. Things that has higher mass, they diffuse slower. Okay, so if they're heavy, then they move slowly. If they're light, then they move quickly. So if you have, say, a container, this is in your textbook. So I soak this cotton wool in one gas X, and I soak this in Y, and they diffuse. And if at one point we see a product here, the X and Y has reacted. So what can we conclude? We can conclude that X is lighter and Y is heavier because it moves so little bit and X moves a lot. So means X can move faster, its mass is probably lighter. So X is lighter than Y. That's how we conclude it.